Hey everyone, this is a lesson on ionic and metallic bonding. So by the end of this lesson, you should be able to infer the type of chemical bond that occurs, whether it be covalent, ionic, or metallic, and we're going to focus on those last two today, in a given substance. But before you get started, please make sure to review valence electrons, cations, and anions, so that'll help make this lesson go a little more smoothly. So first, we're going to focus on ionic bonding because this is the biggest one for you to understand of the two that we're looking at today. And ionic bonding is bonding that involves a transfer of electrons from one atom to another. So this is a full transfer. One atom is gaining, one atom is losing electrons. So when an atom gains or loses an electron, the number of protons and electrons are no longer equal, so they become ions. So when this happens, the atom is not stable because it's no longer neutral. And just remember, again, for definition's sake, an atom with a positive or negative charge is called an ion. If it's the negatively charged ion, it's called an anion. If it's the positively charged ion, it's called the cation. And when an anion and cation are close together, they will be attracted to each other, which will form what's called an ionic bond. So this is an electrostatic force between ions that cause them to go together. So what's important to see here is you do not get the atoms together first and then transfer the electrons. You actually have to transfer the electrons first, form the ions, then the ions are attracted to each other to form that bond. And here's just a quick picture to kind of show you how that happens. Sorry, my son is crying. When the metal and nonmetal combine to form a compound, there is going to be a transfer of electrons, and then the compound that's resulting is your ionic compound. So ionic compounds are extremely stable, one of our strongest types of compounds that we have. They have high melting points and high boiling points, like high enough that we can't reach them in the labs that we have in high school. And then most of them are going to be crystalline solid, which means that they have very specific angles that the ions the ionic bonds form at. So like if you were to hit it with a hammer, it's going to break at those angles. So it's not going to just shatter like glass or anything like that. And these compounds will only conduct electricity if they're dissolved in water or if they are melted. But for us, the only way we can do that is dissolving it in water. Remember that an ionic compound forms between a metal and a nonmetal, or a cation and an anion. Okay, your cation, which will be your metal, loses electrons, whereas your nonmetal gains electrons, forming that anion. And then we look at our valence electrons here to see how many electrons are actually transferred. Every atom wants 8 electrons on their outer shell, so that's our octet rule. So we're going to gain or lose to get to 8. If you lose, it's because you want to lose that outer shell and go down to an inner shell that has 8. If you gain, it's because you want to fill up that outer shell. So an example here is sodium and chlorine to form NaCl. So we've got sodium, which takes a +1 charge because it loses 1 electron. Chlorine, which takes a -1 charge because it gains 1 electron. And then together they form NaCl. So here's just a little GIF to show you how that happens. Okay, so you can see the electron is transferred first. We form the ions, and then they come together to form the ionic bond to make the ionic compound. So now we can talk about metallic bonding. And here, there's a couple of phrases to know about the electrons, which is what's important here. So in a metal, our valence electrons are free to move among the atoms. So we actually will have metal cations with valence electrons just kind of flowing around them. So the electrons of the atom of the metal are easily shared with other atoms of that same metal. And this is called metallic bonding. So we're not really transferring electrons, and we're not sharing them in the sense of what like covalent bonding is, which we'll learn about later in this unit. But we are letting them kind of just do-si-do between cations here. Very loose connection. So metallic bonding allows your metals to conduct electricity, so we know they can conduct electricity, be malleable, which remember means hammered into sheets, and ductile, which means stretched into wires. And I do want you to know a couple phrases here. They're not on your notes, but we want to know these. I don't know why they're not on your notes. But when we're talking about the electrons in metallic bonding, there is one big phrase to know. We refer to these as a sea of electrons. So like CSEA of electrons. Because they're able to just kind of flow in and out of your cations. Some other words or phrases to know are delocalized electrons, mobile electrons, free-floating electrons. All of those mean that your electrons are able to move in and out of the metal cations, which is what gives them the properties that they have. And then we have one last definition here, which is an alloy. And an alloy is a mixture of two or more elements where at least one of them is a metal. In most cases, you have a lot more metals in the mixture. And some common alloys, just so you have some examples here, are brass, bronze, sterling silver, and stainless steel. So this is what we're talking about. We've got our big metal cations here, so you could see those. And then the electrons are just kind of flowing in between like waves in the sea. So now that we've finished this lesson, you should be able to